2 root 12 over 6 root 18. So what happens with any of these radicals where we're simplifying them? There's always multiple ways. Anytime it's a fraction, there's always multiple ways, multiple things you could do. So what I'm going to do is I'm actually going to solve this one twice using two different methods. So the first method I'm going to use is I'm going to simplify everything first, like a fraction, because I like this method the best. And the reason I like it the best is it makes things smaller really quick. The smaller stuff is usually easier to deal with. So I notice for 2 and 6, I know 2 goes into both of those. So I'm going to divide 2 by 2 and 6 by 2. 12 and 18, 6 goes into both of those. So I'm going to divide 12 by 6 and 18 by 6. So 2 divided by 2 is 1. 12 divided by 6 is just root 2. So 1 root 2 is just root 2. Over 6 divided by 2 is 3. Root 18 divided by 6 is root 3. So I have root 2 over 3 root 3. I can't really break anything down. There's nothing I can do now, so I have to rationalize the denominator. So I'm going to multiply top and bottom by root 3. So just the root. I don't multiply by 3 root 3, just by root 3. So root 2 times root 3 is root 6. 3 root 3 times root 3, well, that's 3 times root 3 times root 3 is just 3. So I end up with root 6 over 9. And this is the answer. So what I'm going to do is I'm going to kind of do things in a different order. So it's not so much a different method as just different tools we have. And then what you always have to do is you always have to repeat these steps though. So the different things we can do is we can reduce as a fraction, we can simplify the radical, and we can rationalize the denominator. It's those three things. You only ever should rationalize the denominator once, but the simplifying and the reducing like a fraction, you should always check at the end to make sure you can't simplify or reduce anything, okay? All right, so I'm going to do this example again, but this time, instead of simplifying like a fraction first, I am going to simplify the radical first. So I'm going to break down the 12. I know 12 is 4 times 3, 4 is 2 times 2, so I can pull that 2 out. So I know the numerator becomes 2 times 2 root 3 over 18 is 9 times 3. 9 is 3 times 3, or 9 times 2, and 9 is 3 times 3, so I end up with 6 times 3 root 2. So I get 2 times 2 is 4, so it's 4 root 3 over 6 times 3 is 18 root 2. And I'm going to simplify like a fraction now. 4 and 18, 2 goes into both of those, so I'm going to divide those both by 2. So I end up with 2 root 3 over 9 root 2. And now I'm going to rationalize the denominator. I can't simplify the radicals. I can't reduce as a fraction. Rationalizing I usually do as a last resort. So timesing top and bottom by root 2, I end up with 2 root 6 over 9 times 2. 9 times 2 is 18, so I get 2 root 6 over 18, but now I can simplify the fraction again. 2 over 18, I can divide both of those by 2. 2 divided by 2 is 1, so it just leaves root 6 on top. In the denominator, I just have a 9. So I get the exact same answer, but it's just a different order. Okay, so it's really three tools again that we have. We can always reduce like a fraction, you can simplify the radical, and you can rationalize the denominator.